So today we're going to look at solving quadratic equations by square roots. And so that's another just different strategy that we haven't looked at yet. We looked at it a little bit, or you will look at it when you do completing the square as well. So this would be a good strategy for when something is not factorable. So what we're going to learn first, some of you may see in geometry or trigonometry, but it's how to reduce a radical expression. So I wanted to first show you the product property of radicals, which just says that if you have two different things that are being multiplied that are both under a radical, you are allowed to combine them under one radical. And then we know that the square root of 3 times the square root of 3, if that is the square root of 9, that simplifies to just 3 without a square root, because the square root of 9 is 3. So it makes something like the square root of 2 and the square root of 50, which are both, neither of them are perfect squares, so I can't take this further. If I multiply them together, voila, I'm at the square root of 100, and that I can reduce to just 10 by itself. So the same thing in number 3, I can make that 36, or the square root of 36, and that reduces to just 6 by itself. So where this is useful is when we get something that is not a perfect square, but we can put it into this idea of reduced radical form. So this is something to just start thinking about and trying. If you get the square root of 24 as your answer, you've got the right answer. There's just one step that you could try to reduce the radical. So when you're doing these strategies like quadratic formula or completing the square or square roots, if you get to the square root of 24, great, you did the steps correctly. I'd like you to try to take it one step further using the reduced radical form. So the square root of 24 has a perfect square that is a factor. So what is a factor? So a factor is something like 1 times 24, 2 times 12, 3 times 8, or 4 times 6. Those are all the factors, so they're integer multipliers that when you multiply them together, you'd get 24. Only one of these is in our list of perfect squares. So remember the list of perfect squares? 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25, 36, 49, 64. Let's see, that's 8 squared. So 9 squared, 81, 10 squared, 11 squared, 12 squared, right? So we've got this list of perfect squares over here. There's only one of those values besides 1. 1 is going to be a factor of everything, but that is a factor of 24, and that would be 4. So what I'm going to do is I'm going to rewrite the square root of 24 as the square root of 4 times the square root of 6. Right? Because 4 times 6 is 24. I can take the square root of 4 and evaluate that. The square root of 4 is 2. So I can reduce radical form, the square root of 24, to 2 root 6. And I'm just going to show you that these are all equivalent to the same number. So on my calculator, the square root of 24 and 2 square roots of 6 are both 4.8989. They're the equivalent. So whether I call this rounded 4.9, square root of 24, 2 root 6, they're all equivalent numbers. So when I look at 72, I want to think about all the factors of 72. So 1 times 72, 2 times 36. I don't know if 72 is divisible by 3. It is. 3 times 24. Is 72 divisible by 4? 4 times 18. I mean, you could go through this whole list. Let's see. What would be the next factor? 6 times 12, 8 times 9. So you want to look for the biggest perfect square. So what I usually do is if you start at the top, 36 is the biggest perfect square. 4 and 9 are also factors, but you want to pick the biggest perfect square to get fully reduced radical form. So this is the square root of 36 times the square root of 2 is equivalent to the square root of 72. So I can simplify this to 6 root 2. And the square root of 300, the biggest perfect square factor would be 100. So I would do the square root of 100 times the square root of 3 which simplifies to 10 root 3. So when I talk about reduced radical form, that's what I'm talking about. So here are the steps for solving a quadratic equation using square roots. So it says taking the square root of both sides of an equation maintains equality, just like, adding 2 to both sides or dividing by 4 to both sides. And it's helpful when there's only an x squared term, not an x term. So here's something that's important. When you take the square root of both sides, you must make your solution positive or negative because 2 solutions could be produced. So for example, the equation x squared equals 4 could have 2 solutions. I could plug in 2, 2 squared is 4. I could plug in negative 2, in parentheses, negative 2 squared is 4. So here are the steps we're going to do. We're going to isolate x squared, take the square root of both sides, and write the solution in reduced radical form if necessary. All right, so we're going to do these 5 examples together, and then you are going to try some guided practice on this and let me know if you have questions. So solve for x. See how there's only an x squared term? There's no x term. So I want to get x squared by itself. So my first step would be to add 7 to both sides of the equation. So I get that x squared is equal to 36. So now I can take the square root of both sides of the equation. So my solution is that x could equal 6 or negative 6, because I want to take plus or minus my solution when I take the square root, because if I plug it back in, right, 6 squared would be 36, minus 7 is 29, and negative 6 squared is 36, minus 7 is 29. So there are 2 solutions, just like this quadratic would have 2 x-intercepts. Example 2, again, I only have an x squared term. I'm going to start by dividing both sides of the equation by 5. What is 80 divided by 5? It is 16. Hey, that came out to a perfect square again. Nice. So I take the square root of both sides, and x is either 4 or negative 4. So it came out to a perfect square again. I didn't have to do reduced radical form because it was just a perfect square in and of itself. All right, can't keep happening, right? So let's see. Now I need to get this x squared term by itself. So order of operations, my first step is to subtract 5 to the other side. So now I have 3x squared equals 36. So what's going to be my next step? I have to get x squared by itself first. Even though I'd like to take the square root of 36, I can't. I have to divide by 3 on both sides. So I get that x squared equals 12. So now I need to take the square root of both sides. When I take the square root of both sides, I've got to do some reduced radical form on my 12. So let's see, what are the factors of 12? Well, 4 times 3, right? Square root of 4 and the square root of 3. 4 is a perfect square, and 4 times 3 is 12. So my final solution is, remember, I can do plus or minus, and then this would be 2, and this is root 3. Right? That's the same as saying the square root of 12 or negative square root of 12. So this is just the reduced radical form of that answer, and I've been doing this type of answer up at the top. So whether you write plus or minus 2 root 3 or 2 root 3 or negative 2 root 3 or root 12 or negative root 12, you're giving the same type of solution. All right, so example 4, do not FOIL out a binomial. If you see a binomial, great, you can do square roots of both sides. So first, I need to get this squared term by itself. So I'm going to divide both sides by 2 to start. So I have x minus 2 squared equals 20. Now, technically, this squared term is by itself because that negative 2 is inside the parentheses. So I'm going to take the square root of both sides. So I have x minus 2 equals, let's see, I can break down 20 into 4 times 5, right? So 4 becomes, or square root of 4 becomes 2, and then the square root of 5 stays the square root of 5. So I've got x minus 2 over here, right, because the square root and the square cancel each other out, equals positive or negative 2 root 5. My last step is that I still need to add 2 to the other side of the equation. So 2 plus or minus 2 root 5. Those would be my two solutions. What does that even mean? It just means I could take on my calculator 2 plus 2 root 5, which is what, 6.47, 2 minus 2 root 5, which is negative 2.47, right? So those are just my x-intercepts on my graph. This is just the exact representation of that decimal. All right, so this would be a good time to pause the video and try example 5 for yourself before I go through the answer for you. So now I'm going to go through the answer, so hopefully you paused the video and tried it first. So I need to get this x plus 3 squared by itself. So my first step is to add 32 to the other side. So 2 times x plus 3 squared equals 32. So I'm going to divide by 2 on both sides. So x plus 3 squared equals 16. Beautiful. I've got a perfect square. So when I take the square root, x plus 3 equals 4. I'm going to write it as two separate equations, or x plus 3 equals negative 4. So plus or minus 4, if I write it as two separate equations, I think it's easier for you to see the final answers. Either x is positive 1, right, because 4 minus 3 is 1, or when I subtract 3 over here, x equals negative 7. So you want to be careful. If you get an integer, you don't want to write plus or minus 4, and then this becomes plus or minus 1, right? This is 4, this is negative 4. So when you subtract 3, you get 1 or negative 7. So now you're going to try the guided practice and submit it for today.